Welcome back, ladies and gentlemen, to the live demonstration area, the place to see revolutionary technologies for the next 2 days. Now we are very pleased to welcome Magnum Venus Products. Magnum Venus Products is a global manufacturer of fluid movement and production solutions for industrial application in composites and adhesive markets. Charles Turr has over 3 decades in composites industry and is a renowned expert in resin transfer molding and infusion technology. Building on the silicone membrane construction knowledge that we saw yesterday, Charles is going to now show us MVP's cutting-edge injection technology. Charles, the demonstration floor is yours.
Thank you very much. Welcome, everyone, and thank you to come here for the demo. So as we explained, on 3 days, we run 6 different demos. And the demo we are going to run now is to inject a part with a silicone bag. So you can follow part of the presentation here, and then after that, I will inject the part. So this is a silicone membrane in details. As you can see here, we have a groove on the mold where we load the membrane to be sure that we locate the membrane perfectly. Then we have nearby a vacuum channel where we can pull on one place the vacuum to help the injection. And then we have what we call the resin channel, which is collapsible. I'm going to show you that. So that's the part we produce. And with the collapsible channel, the big advantage is that you will not have any excess of resin. You will even not be able to tell how we have injected the part. That's the idea. So the key point is the closing system. We decide to make a groove because like that we can locate perfectly the membrane. Then the resin network. How do you inject the resin? Are you going to inject fast because you want to produce a lot of parts, only 1 part per day? That changes everything. Fast injection, of course. We are able to inject that kind of part in 2-3 minutes, according to the quantity of the resin channel we do. No trimming, so we are able to cut the glass precisely on the part border. Then as you can see here, when we demold the part, we don't have to trim it. And no pipe to clean or to change. We want a process which is clean. We don't want to see people scratching the gel coat or the resin on the flange of the mold. When you demold the part, the mold has to be clean. The membrane has to be clean. We don't want to have any resin on the pipe. It's wasting time, it's wasting money. So you have to think about that before you build the membrane. When we build a membrane must be 3 millimeters thick. No more than that, it's enough. The point is, we do recommend to reinforce the membrane. Why? Because if you don't reinforce the membrane, this is what will happen. If you reinforce the membrane, that cannot happen. So again, the membrane you expect to produce between 500 to 1,000 parts, so it's better to build it properly. In some place, you don't want any extension or elongation of the membrane, but in some place, you want elongation. That's why we have 2 different cloths to reinforce the membrane. It's just to explain that a silicone membrane is a little bit more technical than what it looks. So as I explained, we have 2 different cloths, stretchable, non-stretchable and stretchable. And that's the mold and the groove. So it's working like that. We load the glass. After that, we load the resin stopper. Why? Because we don't want to contaminate the pipe of the vacuum. Then we load the membrane. When we load the membrane, we first apply the vacuum on the groove to seal the membrane perfectly. And then we pull the second vacuum on the top of the vacuum channel to assist the resin flow. So because the channel is running all around the mold, 1 vacuum port is enough to pull the vacuum on the full part. And then we do inject the resin. So this is the collapsible channel, how it's working. If you look on the part, then we have the channel deflected and not deflected. As you see, we have injected the part, and when we demold, we cannot see how we have injected the part. So how it's working? We load the membrane on the top of the mold after we load the glass. We pull the vacuum to assist the resin flow. And then we pull a second vacuum only into the collapsible resin channel to deflect the membrane. on the resin channel location. Then we have a free channel to inject the resin. At the end of the part, when we have injected the right quantity of the resin, we stop pulling the vacuum into the resin channel, and the resin channel come back on its original position. No resin waste, no excess of resin, no shrinkage. So let me show you how it works. We have a membrane here. We have a resin channel here, and I'm going to apply the vacuum now on it. This is what happened when I pull the vacuum. Yeah, I'm sorry, I'm not well connected. Voila. This is what happened here when I pull the vacuum. I deflect, you can see that on the video. I deflect the collapsible channel. Then when I stop pulling the vacuum, everything is coming back flat. So you will not see how we have injected the part. So we have an injection port, which is here, which is a special injection port that we made like that. We have a 3D printed mold. We just close the mold, we pour the silicone, and after that, we demold that. The advantage of this insert is there is a lips. So when you apply the vacuum on the pipe, you open the lips, and the resin can flow. But as you can see, it doesn't flow on the other side. So you are able to manage your infusion. You can inject everywhere at the same time, or you can inject only on one place or on one line as you like. And this is a changeable resin port. So if after 200 parts, it starts to be a little bit damaged, you don't have to redo the membrane. You remove it from the membrane, and you bond a new one. So this is a 3D printed mold, easy to do. And then you can have a sequential. So the sequential is working like that. Instead to have a straight one, you can have a cross one. So with 4 lips. So you can send the resin there, 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 as you like, step by step, or at the same time. With this technology, you can do everything. So before I'm talking about the way we build the membrane, let's inject the part and show you how it's working. So I have the mold here, where I have loaded the glass. I have trimmed the glass precisely on the part border, so I have a step in my mold to show me exactly where I have to stop the glass. That's very helpful in production for the operator. Then I put what we call a resin stopper, which is a band of Coremat, between the part border and the resin channel, which is on the border of the silicone membrane. And now I'm going to load the membrane. So I just put it properly on the groove, like that. I will put that properly, and I will put my vacuum here also properly. So now what I can do, I can apply the vacuum to seal the membrane. So now the membrane is sealed. And then I apply the vacuum to assist the resin flow. The vacuum is coming from here. It's coming from here, below the vacuum channel. So now everything is under vacuum. Now, what I have here, I have a valve. And I have an injection valve, which is connected to the injection machine. So when I will start to inject, I send the air signal to the valve. The valve will open, the resin will flow in. But at the same time, I send the air signal to this vacuum valve. And that vacuum valve automatically will send the vacuum to collapse the resin channel. The problem is, when I will finish the injection, if I forget to stop to pull the vacuum into the resin channel will stay full of resin. The valve automatically, when the machine will stop, will close and will close the vacuum on the collapsible channel. But to close the vacuum is not good enough. Why? Because you're still under vacuum. You need the air to come in. So that valve stops the vacuum, but let the air passing through. So then the collapsible channel can go back on its original position, which is flat. So here we have an injection machine. That's the most important part of the demonstration, is the machine who do the job. So we have a predetermined counter. We know exactly the quantity of the resin we have to inject, so we set up it, we reset it to 0, and when we start, it will inject automatically the machine. We have on that machine a part which is very important for security, which is the MPG. What happened? If anything happened during the injection, the pipe blocked the resin cannot flow, we'll have the back pressure to the machine. The machine is very powerful, and by the pressure, the pipe can break, and you will have resin everywhere. When we have a back pressure on that machine, it comes back to the MPG, and it stops automatically the machine if anything happens. That's a very important security on the machine. And then we have a catalyst pump pressure, we have a gel alarm, and so on. So all the options, and we have plenty of different machines with different options. So let's inject the part now. So I start everything. You must zoom a little bit if you can see the resin flow. And now we inject. So we start to inject. The valve opens automatically. And the resin is coming in. So now we don't see anything because the resin fills the resin channel first. Sorry, it's not easy to see because it's yellow on yellow. Voilà, so you have the resin flow along the resin channel, and then you will see the resin coming here and coming here. So you can see here the resin coming. I know it's not easy on the video. Yeah, now it's better. You can see the resin flow here coming. So you have the distribution along the resin channel. So at this time, you have nothing to do. The machine will stop automatically. So what you do, you go to work on another mold. The machine will stop. And when the machine will stop, the only thing you have to do is to flush the machine. If you forget to flush the machine, when the machine stops, automatically there is a whistle who will make noise to remember the operator that he has to clean the machine. So everything is under control. So you can see the resin flow step by step. There is no need to inject too fast. We can manage it. We have a sensor that we can connect on the machine to control perfectly the machine and the injection. But here is not required. We just inject at the right speed. So we know we have inject part before. We set up the machine properly, and we just let it doing the job. So you see that the resin flow is regular. So we have inject, almost 90% of the resin. The point is, you have to remember that the resin channel is full of resin. So you cannot stop to inject when the resin is on the border. You stop to inject only when you have injected the right quantity of resin. And the resin which is on the collapsible channel, we finish to fill the part. Voila, the injection is finished. So what happened now? As I explained, we don't have more vacuum. We don't have any leak because that valve let the air passing through. But then the collapsible channel come back, and you will see that the part will be finished to fill by the excess of resin that we have into the resin channel. This is why you need to inject the right quantity of resin. Okay? Now what we have to do is to flush the machine. So again, this is automatic. I push the flush button on the machine now, and I just flush. So the acetone cleans the machine, and when it finishes to clean the machine, it passes through the valve and cleans the valve automatically. You can work clean. Okay? So that's it. The part is finished. The part is injected. Now we just have to leave it cure. Okay? So as I explained, it takes around 3 minutes to inject that. We can go faster. If we put more resin channel, we can inject this part in 1 minute. It depends on the quantity of the resin channel we put. We have different strategies. So let's go a little bit on the presentation. So you can see different membrane, different size of membrane. So it can be small, it can be big. We have made membrane until 36 square meters. So then, as you can see, we close the membrane, we inject the part by the resin network, and then after that, we demold the membrane. So at MVP, we do recommend to not leave the membrane too long on the part. Why? Because the styrene attack the silicone. So as soon the resin gel, as soon you demold the membrane. Even if the part is not completely cured, you leave the part on the mold, but you remove the membrane. Never leave the membrane overnight, and never leave the membrane over the weekend. That's not good. You will decrease the life of the membrane. We have customers who have produced more than 1,000 parts with the same membrane because they take care of their membrane. So you see, you can go for long part. The main advantage is that the resin channel that we use is a 40 mm resin channel. So because of that, we can send the resin to 15 meters. When we do infusion with the spiral tube, it's 10 mm diameter. So every 4 meters, we have to put a new resin port. Here, with one resin port, we can inject large part, long part. So this is a production of part. As you can see, here we do training. So we teach customers how to make the membrane, and then we inject the part with them to teach them how to do it. Same, here we were in Egypt, now we are in Poland. Small part, medium part, large part, all the same. That's how the vacuum valve is working. We have the resin channel, we come with the valve on the top of it. Then we come with the vacuum valve. We have an air connection, the air signal coming from the machine. We send the air signal to open the valve when we inject the resin, and at the same time, we open the vacuum valve. Then it collapses the resin channel. We do inject the resin. When we finish to inject the resin, the machine stops to send the air signal. At this time, the valve closes automatically, and the vacuum valve stops. So it stops pulling the vacuum, but it's not enough. It has to let the air pass through, and that's what do the valve. So parts for transportation, as I explained, 1,200 parts with the same membrane. Long part, 11-meter part, one injection port, ACOM in Poland. And then, as you can see, we can stop precisely the part, the fiber on the part border. So no need to trim the part, which is nice because 11-meter part is boring to trim. Then, that's the way we produce with a good team. That's the secret. Sequential injection, as I explained, can do larger parts. Here is a company in Spain who produce a water tank. Sandwich production of part in Italy, company Metra, is a support for swimming pool. Foam. Injection. As you can see, we have the resin network designed to go fast to inject the part because they want to produce several parts per day. And that's the part after they demold. And you see when they remove the membrane, everything is clean. And it has to be like that. Flange protector. Tomorrow we'll show the possibility to combine composite and silicone. And what we do it to protect the flange when we spray the silicone. Instead of using thousands of rolls of tape and plastic, we just protect the flange with a composite part covered by silicone. We spray the silicone, and then we remove. Here is a part with undercut, so it's a split mold with the membrane. Also here is a Bosch dashboard. So we make the mold, split part, all organized by vacuum. Assemble the part, load the gel coat, inject the part, and demold the part. So we can go also for complex parts. So thank you for your attention. Our next demo this afternoon will be a demo where we will infuse the part with a plastic bag using the SVB technology.
You were so quick today, I wasn't ready. If you have any questions for Charles, take advantage. You have 3 decades of expertise here. I'm sure he would love to answer any of your questions. We have a mic right here.
One thing I can show you is the back side of the part, where you don't see the resin channel. That's the part after we demold. You cannot tell how we inject the part except a little mark on the injection port here. There is no resin waste. And the part, we just grind a little bit the border, and the part is directly finished. So that's what we expect. a lot of time saving and quality saving.
Okay, no questions? Charles will be back here today at 3:30. So don't hesitate to come back and see another demonstration. And you can also take the time to come and speak with him now or visit the MPV stand at Hall 5, U58, if you would like to have further discussions with Charles and the MVP team. I'm sure they would love to answer all of your questions. Thank you so much, ladies and gentlemen, and thank you, Charles. Our next demonstration will be taking place at 11:30. Ladies and gentlemen, with Aerovac Composites 1, so don't hesitate to come back. Otherwise, enjoy your day at the Czech World Show. Thank you.